So in this video, we will learn about how to solve shorter distance after row addition queries 1. So this problem states that we are given n nodes and we are given some queries. So n nodes means that there are n cities or n nodes that are pointing to that is pointing like this in sequential manner. So zeroth node is pointing to one first node is pointing to two, and so on. So this will be the initial case when n is equal to 6, this becomes something. When n is equal to 4, this becomes something like this. Zeroth node points to 1, 1 points to 2, and 2 points to 3. So this is the initial case always. And we know that since this is the case, the shortest path from zeroth node to last node will be 5 minus 1. 1, 2, 3, 4. So here the minimum path from zeros to last node will be 4 minus 1, which is 3. 0, 1, 2, 3. So initially that will be the case. Now we are given some queries. So first query, which is 2 comma 4, suggests that second node will connect to fourth node. So when this happens, tell me the shortest path from zeroth node to last node. So this will become 1, 2, and then 3, right? So this will be the shortest path from zeroth node to last node. Now when query becomes 0, comma 2, another node comes from 0, comma 2. Now give me the shortest path from 0 to 4, which is 2. Similarly, for other queries as well. So this suggests that given some queries, tell me the shortest path from 0th node to last node when the node connection happens at that query. So when 2 connects to 4, tell me the shortest path. When 0 connects to 2, tell me the shortest path, and so on. So this is a classic graph traversal algorithm, and we can implement either depth first search or breadth first search. So breadth first search is simply you go to zeroth node and then you find all the neighbors of it, and then you push all the neighbors into a queue and then do the same until you get to the last node. Depth first search is you go to the zeroth node, you go to its immediate first neighbor you find, and then you go to its again immediate first neighbor you find until you exhaust all the neighbors or you get to the last node. So we will employ a breadth first search here. So let me just write down the algorithm for a breadth first search function BFS and adjacency list. It will take adjacency list and it will also like take n, which is total number of nodes here. So here first, what I will do is I will initialize a visit set, and this will be a new set, and this will be of type number. It will store numbers, and I will initially add 0 to it because like we start at 0th node, so I'll add 0 to visited set, and I'll create a queue which will store the nodes. So I'll create a queue of type number, and it will be an array of number. It will be a double array, nested array of number. Why is it so? Because first will store the node, the other will store the shortest path up to that node. Uh, so the first will store the node that we are at, and the second will store the shortest path up to that node. So here it is 0. Now I will loop till my queue has some nodes in it or queue has some items in it, and I will extract the first node and the length up to that node using queue.shift, and then I will loop through the neighbors for const neighbors of adjacency dot get node or array or an empty array if that is empty, and then I will check if my neighbor is in visited set or not, because like if it is there I don't want to add that neighbor again because it will go into a cycle. Visited dot has, if not visited dot has neighbor, I will add this to my visited set, and then I will also add this to my queue. So it will be neighbor and then length plus 1. Why plus 1? Because up to node I had the minimum length of len, But when I go to its adjacent neighbor, it will get one will get added to it since I'm moving towards one node here. So this is the whole BFS algorithm. And we also need to place a check here. If my node reaches to the last node, I should break out of it because this is what I want. I just want to reach till my last node and I will return length here. And at the end, I will just return -1 in case it doesn't happen. In this case, it will happen, but yeah, I'll just return -1 here. So this is my BFS algorithm, and this is all we wanted here. Here we will initialize an adjacency matrix or adjacency map. It will be like this. And initially, we know that the adjacency map will look like this. Zeroth will have a neighbor as 1, 1 will have neighbor as 2. So I'll just loop through the nodes and I will set the adjacency map here to I plus 1. Why I'm setting it as array? Because I can have multiple neighbors. So I'm just making it possible to add multiple neighbors to a single node. And then I will loop through queries, const queue of queries. Now I will add, now since I know that second node will get a connection to fourth node, so I'll also add this in my adjacent map. So I'll add this as const neighbor or const um, neighbor equal to adjacency dot get q0 or an empty array, and then I will add this to my neighbor. Um, I'll add this to my node. I'll name it this as node and node dot push q1. So I'll added adjacency map of this, like 2 gets connected to 4 now, and then I will BFS on this. I'll BFS and this accepts adjacency and n, and yeah, so I'll also create a resultant array since we want the result. So this will give us some response, and I will push this response to my resultant array, and at the end we will return resultant array. So what is happening is this BFS gives us the shortest path, and we store this in response array, and then we push that in a result array, and then we return the result array. So let's run and see if it works. So it does work. I'll submit it, and we can see it works. So this was it, and I'll see you in next one.